Hello everyone, myself Leela Krishnan and I welcome you to this lecture 6 Developments in Design and Process Monitoring. From the previous lectures you would have seen about the various additive manufacturing technologies and how it has evolved from its initial stage and how it has been used from different domains as well, and starting from rapid prototyping and making some fixtures, and slowly it has gone for some customized products development. Then recently we are seeing like it has been into many different domains as well. But when it comes to additive manufacturing itself, inside it has got various process steps that we call it as again domains, and here we have like part identification, order management system, design and optimization, build preparation, process simulation, build processor, printing technology and process monitoring, post processing, manufacturing execution system. All these things comes under AIM workflow, and even with respect to our topic, that is design and process control, each topic has got some of its input inside these domains. But when it comes to post processing, we do not consider this one because there we do not see its involvement. And when it comes to part identification, we can see that we need to identify a particular component which is capable of being additive manufactured, and in such a way that it has to make some sense in the reality to get it printed in AIM. And coming to the next one, that is order management system. One of the critical aspect in additive manufacturing is preparing the code. The code preparation comes with multiple variables like raw material consumption, support structures, and the supports has to be removed during the post processing, and there can be different type of post processing which will be involved, and design wise there will be some guidelines in implementation. All these things has to come under the code. So starting from automated code generation until the managing the order until releasing the PO, this needs to be maintained. So order management has got a very good important aspect with respect to design, because the based upon the design, so there are certain software tools which can identify what type of post processing is required for it and what type of orientation is required, and based upon the orientation how much time it will be considering and how much support structures it will be considered. So all these things are being calculated by the software tool itself. And coming to the design and optimization, in this case we already seen like many design related software tools like CAD tools you can consider, like SolidWorks, Autodesk Fusion 360, CATIA, and many such tools are available. Still, when it comes to additive manufacturing aspects, we need to implement certain guidelines, and even we need to optimize the design for the purpose of additive manufacturing. So it is really required that to implement design and optimization, and by using latest features available in the softwares. And now coming to the build preparation. When it comes to build preparation, we have work like fixing and editing the mesh files, because whenever we do make some design, we basically convert into some STL file formats, and that STL file formats need not be perfect all the time. So there will be a operation of fixing and editing the STL files based upon our requirements, and the other things are support structure creation and orientation setting up. So these kind of things comes under build preparation. And next comes the process simulation, and in the case of process simulation we have different variety of tools, but it is not required for all the type of technologies. Certain technologies where cost involvement is very huge, then we will be implementing the process simulation for that area. And coming to the build processor, each technology and each machine manufacturer might have a different type of build processor for their requirement, and where it generates the machine code can be read by the machine itself, and it plays a very important role because each machine will have a different type of firmware, and based upon the firmware's requirement we need to generate a code. Next, coming to the printing technology and process monitoring, it involves two things together, that is printing technology, which you would have seen in the AM technology landscape, where you would have gone through about different type of AM technologies starting from material extrusion, VAT photopolymerization, binder jetting, material jetting, powder bed fusion, directed energy deposition, sheet lamination. These kind of things you would have seen in the printing technology. And why this process monitoring is coming inside this is, the reason is the process monitoring happens during the printing process. So that is why like we are bringing it here, but whereas we will not be discussing about printing technology in detail. The reason is we have already discussed, and we will be discussing more about process monitoring things in this. And finally, coming to manufacturing execution system, in the existing manufacturing setups or production setups, this kind of MES software tools are mostly available, but when it comes to additive manufacturing, it is not highly available. And in our case, we will see what are the various things involved in the manufacturing execution system. Now let us start with part identification. As I earlier told you, part identification is like identifying the perfect part for additive manufacturing. There are different factors which is involved into it, and even there are different benefits we get out of it. Now these are the three different factors, main factors you can consider. There are some other factors as well, but these are the three different factors which are involved in the part identification step. First thing, part reduction, second one is sustainability, and the third one is supply chain improvement. Now let us see about part reduction. So you can see one particular component here. This is like some kind of assembly which is having a multiple number of components in this place, and which has been converted into one single component that is manufactured through additive manufacturing. So the reason why part reduction comes into the picture is, initially for the purpose of manufacturability, people will be making one single component into multiple different components. You can see that here there is two different type of stems which cannot be manufactured in traditional manufacturing method. The reason is there will be a undercut, even in this place also there might be some undercuts, and there is a hollow section inside it which is not a feasible method to be manufactured in a conventional machining setup. So that is why like people go for multiple components like this and then assemble it together, then the task is completed. But taking the design freedom of additive manufacturing, now again we are trying to bring it together. Now what we could able to do in the place of part identification is, we can see such a kind of component which is very critical in design, and we will try to minimize the number of component, and we will try to monolithize the component to make it in a better way. So this is one such factor in doing the part identification. The second one is sustainability. You can see one such example here in the image below. Material is there is a billet of material which goes under a subtractive manufacturing method, that is a conventional machining process, and then we are getting the required 3D geometry. But here, since it undergoes a subtractive manufacturing method, there are some waste materials which is taken out. So this is a very huge amount of waste which is taken out from the component, that means a billet of material. But when it comes to additive manufacturing, we are majorly using what is the material required for our purpose, and we are giving it to additive manufacturing, then we are getting the product. Still there are some amount of waste, but it is not that much when compared to subtractive manufacturing methods. The reason for this particular waste in additive manufacturing is because of support structures. And as we can see that still this waste in the subtractive manufacturing can be recycled, it is possible, but still when it comes to the sustainability factor, it takes more amount of energy to go back and get itself changed into the billet of material. So, that is the reason the additive manufacturing has been chosen as a best method with respect to sustainability. Next comes the supply chain improvement. Now, there are certain cases like we might be getting some components from abroad or any particular place where our requirement is too far. Then when it comes to supply chain improvement, can see that in the case of ship related setup, there can be a requirement of a particular component. When they are in the ship, there need not be all the accessories to be maintained in the warehouse of the ship, but when it comes to additive manufacturing, the designs can be stored in the digital inventory, and whenever there is a requirement of a particular component that needs to be replaced, then immediately it can be manufactured with the AM machine and then it can be replaced. Example which I have told is one such thing, but there are many such examples, and even with our case studies also you could able to see that. Now, let us see how market players has implemented part identification in a software tool. So, one notable player here is Select AM. They have an approach which basically analyzes a CAD model and then assess it with various parameters like lead time, lifetime savings, bounding box volume, maximize part dimensions, total cost per volume, minimum order quantity, and finally yearly demand. Select AM assigns an AM score basically, which helps manufacturers determine whether a part should be considered for additive manufacturing. Recently, this Select AM made the headlines by providing open access to their software package, which enables more companies to leverage this tool for part identification. Another significant contributor here is Cognitive Additive. They also analyze the CAD model and offer an AM suitability score, which basically evaluates parts based on 3 critical factors, that is print quality, design for additive manufacturing, and complexity. That is print quality, design for additive manufacturing, then complexity. Their score ranges up to 100%, which helps us in taking a data driven decision. Also, Cognitive Additive has recently secured a €2 million funding round. Now, coming to the third and fourth players here, which is Octane and Castor. So, Castor is already working on feasibility assessment, that has recently joined hands with Octane to make Octane's presence in the complete ecosystem of AM. Just to add a point here, Octane already has 2 products, one is 3D Expert, another is Manufacturing OS, which covers most of the domain in the AM ecosystem. Finally, 3D Spark, they are also working in the same space for part identification. Now, coming to our second domain in our process, that is order management system. Basically, this order management system is used by the sales team to make sure their quotes are provided in a matter of minutes, and they make sure that all the required details are taken into the picture. Not only the design, and certain aspects like their final finish, what is the material requirement, and what are the tolerances need to be maintained in particular places. So, all these things are taken into picture, and based upon which automated code is getting generated and it is reaching the customers. And whenever we have a very faster code generation system, the chances of getting the orders also is very huge. Now, these are the three main aspects of order management system. One is automated code creation, second one is scalable order management, and the third one is reporting and analytics. As I have already told you, automated code creation actually streamlines the printing process, and it will quickly generate the accurate codes based on specifications given by the client and material cost and production timelines. So, based upon these aspects, these codes are getting generated. The second one is scalable order management. You would have recently seen how e-commerce industry has grown to a very higher level with big players like Amazon, Flipkart. What they do over there is order management, and it is scalable, and again the same thing applies over to additive manufacturing also, because once we are making the complete system in a highly digital environment, the chance of scalability in additive manufacturing is also very huge. Earlier cases, additive manufacturing is being considered mainly for prototyping or minimum production, but currently many new players are coming up, many new technologies also you can consider which are coming up for mass production. That means when we have like something like a print farm where regular production goes on to make a mass production as well. So, in that kind of scenarios, the order management system also need to be a scalable one, where we need to maintain all the orders and we need to make sure all the orders are delivered to the customer on time, where the orders are currently available, and all these systems need to be maintained. Now, coming to the third point, that is reporting and analytics. Again, this is a very important factor when it comes to an industry perspective, where all the reports has to be generated with respect to additive manufacturing, and which will have order trend, production efficiency, and customer preferences, which will make us to make some decisions based on data, like how the customers are reacting to a particular product, and based upon a particular technology as well, how the production is efficiently growing. So, these kind of things it will help the industry to make some data driven decisions. Now, coming to the third topic, that is design and optimization. Here we have major requirement of engineer to work on the design, and already existing designs can be part consolidated, or otherwise it can be optimized using various tools, and even design guidelines can be implemented. So, there are different factors available inside this design and optimization. Now, let us see what can be done with the design and optimization. The first thing we can see is CAD modeling. So, CAD modeling is not a new term in the industry. From long back it has been there. Still, when it comes to additive manufacturing, it is our utmost priority that we need to make sure all our design guidelines are being implemented into the CAD model. So, that factor needs to be considered, and whenever we do some designs for additive manufacturing, there are some design freedoms available. So, those design freedoms can be captured, and that can be implemented in the CAD model itself. Here on the left side we have like 4 different designs. Like first one is connected with the CAD modeling, and second one with the lattice creation, third one with topology optimization, fourth one with generative design. The same particular design, you can see it like it is having multiple variations, and when it comes to the first one, it is like a conventionally made design. That means it is not designed for additive manufacturing, it is designed for conventional manufacturing purposes. But when we are implementing into additive manufacturing, all the design guidelines and methodologies can be implemented into this design and it can be part consolidated. But currently it is not a part consolidated design, but whereas we can do the part consolidation in this kind of existing designs. The second one is lattice creation. Lattice actually plays a very big role, and you can see that there are many type of lattice structures available, and when it comes to the tools, CAD modeling softwares which is bringing this lattice structures creation feature into their software itself. And there are different type of lattice structures available. Based upon our requirement we can try different methods as well. And now coming to the third one, that is topology optimization. In the topology optimization you can see that the red color portions, which means it takes most amount of stress and deformation. There are different methods available in topology optimization. SIMP, there is one method which is basically used for topology optimization in most of the tools. And coming to the generative design, when compared to the previous topology optimization, we basically provide a billet of material, and that means a volume of material from which some aspects of materials are getting removed. That means where the material is not required, that is getting removed. But when it comes to generative design, we have some boundary conditions that is being provided. If this is what my fixture is and if this is what my loading condition is, based upon this requirement the software tool creates a model, that means creates a geometry by itself. So, this is a major difference between topology optimization and generative design. Both gives a very innovative type of geometry. Still it needs to be implemented in most of the industries, like now only many aerospace industries have started to implement this kind of design features in their components. Here we can see various software solutions focused on design and optimization. In the first group we have new players in the design and optimization space. These tools primarily focus on implementing design guidelines or creating lattice structures. So, these are the players, but they are not a full fledged CAD modeling software, but still we have 3D Expert and Diabetics in the same group which is capable of doing the topology optimization and heat exchanger design applications, conformal cooling and other features which is relevant for additive manufacturing. In the second group we have the established market leaders in the design and optimization space. These solutions allow for all type of design modification and optimizations. Additionally, many of these established players are not expanding their presence within the broader additive manufacturing ecosystem. But still we can see some players like Autodesk who have a software called NetFab, and still they have a software called Fusion 360 which is a full fledged CAD modeling software, and NetFab which is a AM software. Same way, like all the existing market leaders also need to come up with their own AM softwares which will help making the ecosystem grow better.